Hi class, it's me. So this is so classic of Miss Yam. I forgot to write down the question that we left off at the end of class today. I know it was a polynomial function in factored form, and I know we were looking for when that polynomial is either less than or bigger than 0. I don't remember which one, but I didn't write it down. So I'm starting with a new question. So are you okay with being flexible? Sorry about that, but I left the room to go to my next class, actually to my advisor group, and I ran back to the classroom to go copy it down, but guess what had happened? The next class had entered that room, and they had erased the board, so I didn't write it down. I'm so sorry. Anyway, so here's the question, or the analog to the question, okay? Let's say we're given a function in factored form, and I want to know when is the function less than 0, okay? We know the function equals 0 at x equals 1 and x equals negative 4. Excuse me, and x equals negative 4, okay? And so the question is this, but when is f of x, which is x minus 1 times x plus 4 squared, when is it less than 0? Okay, this is where we left off. So there's a couple of ways to go about this. Like everything else, there are many ways to go about this. One way is we can certainly use our knowledge of the roots, okay, and do a very preliminary but comfortable sketch of the function. And here I know that I have a root at x equals negative 4, okay. I have a root at positive 1. And I know that at negative 4, this is a root of multiplicity 2. Okay? And I also know that if I were to multiply this function, the factors out, if I were to multiply it out, I know that the degree of the polynomial is going to be degree 3, and I know the lead coefficient is going to be 1. So in other words, the way I figure that out, boys and girls, is I look here, you know, x minus 1 times x plus 4 times x plus 4. I know for a fact that if I were to multiply all this out, I'm going to have 1x cubed, and then the lesser dominant terms, okay? So I know I have an odd degree polynomial, degree 3. Lead coefficient is positive, which means then I know the right end behavior is going to rise, and I know the left end behavior is going to fall. And I know there are no other roots, and I also know that negative 4 is a root of multiplicity 2. So I know, boink, that the function looks like this. And when we use our old information, okay, the old information being basically everything up until now, we are using our knowledge of end behaviors, our knowledge of the nature of a root of a polynomial. We can then say, okay, when is the function less than 0? Well, asking the question, when is a function less than 0, you know, when is the function less than 0, that's essentially asking when is the function, right? When is y, after all, when is the y value below the x-axis, right? Because for all values of x, where the function is below the x-axis, the y values are going to be negative. So what we're looking at here is this, okay? This is where the function is below the y-axis. Now I'm going to go and make something clear to myself. Below the y-axis, less than 0, not less than or equal to. So I don't want to include those values of x where the function equals 0, right? So now I can answer the question, okay? I can say f of x is less than 0 on the following intervals of x, okay? On the interval of x right here, the interval of x that describes this part of the function are values where x is between negative infinity and negative 4. Notice how I'm not inclusive of the negative 4. I don't want to include negative 4 because at negative 4 the function equals 0. And we are never inclusive of an infinite or non-finite number because we can never get there. And the other interval of x where the function is below the x-axis is the interval of x between -4 and 1. All right? So just finishing our conversation from class today, we are now, believe it or not, solving polynomial inequalities, right? We're not solving polynomial equations, we're solving polynomial inequalities. So now, please go to that handout I gave to you at the end of class, and let's take a look at question number 4. Okay, question number 4 from your handout. Question number 4. It's asking you to solve each inequality. Okay, solve each inequality and see where it says give your answer in interval notation and in number line form. I haven't shown you interval notation yet. You can describe your interval using inequalities right here. No big deal. Okay, that's not difficult math stuff. The difficult math stuff is what we're doing right now. So question number 4 says to solve each inequality, you're asked to solve for x, and the inequality is 3x squared. Okay, thank you. Plus, oh wait, sorry. You know what? Let's do number 5. Let's do number 6. Sorry. Oh, here's one of those times when I'm thinking of one of the interims, which was sometimes, Miss Ann, during your screencast, you all of a sudden switch gears in the middle of a thought, and sometimes that drives me a little crazy. And all I can say to that is, I'm sorry. Okay, -x squared minus 4x minus 7 is less than or equal to 4x. All right. So here we're going to solve for x here, and one of the things you'll notice when we started off this discussion in class was solving polynomial inequalities is great when you have the polynomial in factored form and set unequal to 0. We like having the polynomial in factored form set unequal to 0 because if it's set unequal to 0, it makes it very quick and easy to see when the function actually equals 0. So the very first thing I'm going to do down here is set the inequality unequal to 0 and then factor. And when I do that, I get this. And as you've seen probably already, if we're going to try and now factor the left-hand side, okay, factor the left-hand side. Factoring is always easier if the lead coefficient is positive. So all I'm going to do here is divide both sides of the inequality by -1. Now, ladies and gentlemen, when you divide by -1, what does that do to an inequality sign? Yes, it does. It makes it reverse. So did you forget that? If you did, you'll make a little note over here telling yourself that dividing by -1, don't forget to swap the inequality. All right, you understand? All right, fantastic. Now what I'm going to do is factor the left-hand side because we like to factor when an expression is set equal or unequal, in this case, to 0. Okay, so here's what I'm going to write out the sentence. So I'm just going to call this f of x for a second, okay? And here I see that f of x equals 0 at x equals -7 and at x equals -1. And if I'm looking at f of x, if this is f of x, I see that f of x has x-intercepts at -7 and -1, and those roots are of multiplicity 2. -1, -7. They are roots of multiplicity. Did I just say multiplicity 2? Good heavens. Multiplicity 1. And looking back here at the original, now notice I say original function, boys and girls, the original function. And the original function, I resort back to here, the original function before I divided by a -1, right? Because when I divide by a -1, that changes things. Come on in. Okay, this is the original function. Like I subtract 4x, right? This is the original function, right? Set unequal to 0. So here's the original function. The original function is this one, right? F of x equals -x squared minus 8x minus 7. I guess be careful here. You know, when I called f of x this down here, I was calling f of x this because I was looking at the roots, right? The roots don't change whether you divide out a negative or positive. However, you'll see when I subtracted 4x, this is now the original function. A is negative. It opens down, okay, if you remember from parabolas. But anyway, degree 2 polynomial, negative lead coefficient. What that tells me is your parabola is going to look like this, open downwards, right? Now the question is, when is the function, you have to go back here. See, this one's tricky because of some algebra, okay? When is the original function negative? When is the original function negative or equal to 0? Well, the original function is negative or equal to 0 right here, and right here, okay? So again, just try and keep yourself straight in terms of what is the original function, right? Especially when there's algebraic manipulations involved. On these, those are the branches or the parts of the function where f of x or y is less than or equal to 0, okay? So then I would come down and finish, and I would say, okay, the original f of x, which I'm calling right here, this one, okay, is less than or equal to 0, or in fact, you know what, let's just get rid of the is. Let's just be cleaner about this. F of x is less than or equal to 0 on the intervals of x from negative infinity to x to negative 7. Note the inclusive because it could equal 0, and negative 1 less than or equal to x less than or equal to positive infinity. All right, so that's it for this screencast. So this screencast was about solving polynomial inequalities, okay? General rules, set it unequal to 0, and then factor. That allows you to find where the polynomial function equals 0, and then you can do a rough, quick sketch and figure out where the function is either above or below 0. And from there, you can then answer the question, okay? So, hi Lily, hang on a second. On your homework of that handout, please go, you can come on in. Please do on the handout, okay? Numbers, how are you?
Good, how are you?
1, 2, 3, 4, and 5, okay? Oh, look at that. Numbers 1 and 2 already factored for you, and 3 is not factored for you, nor is 4. Oh, this is very good. Lovely, okay? And then I will see you tomorrow in class, everyone. Have a great evening. Goodbye. Hi, Lily, how are you?